sessions, so I'm hitting record now, and I will make the file available for Jonathan by tomorrow morning at the latest.
Okay.
I'll send him a link to whatever email address you guys have used when you signed up.
Right.
Yeah, he'll be able to review the session in a YouTube file format where he can pause it, rewind it, fast forward it, whatever he wants to do. But it's pretty useful if you're covering, especially if you're covering material that, you know, is being explained for the first time or something.
Right. Okay, so I'm going to send you the first page, actually the first dozen questions on his quiz, his most recent quiz.
Yeah, probably won't be able to do more than a dozen, I wouldn't think, but who knows? Let's take a look at them first.
All right. Let's see. He's seeing that here.
Yeah, the only thing, if you're taking them at night, make sure you got decent light.
Yeah, that might have been.
Or use the flash. The flash actually works. It's just sometimes the flash will leave a glare in the middle of the page, and you can't see what's behind that glare. But
Yeah.
go ahead and take it and send it, and we'll see what it looks like. Now, this is the last time you'll ever have to type out my full email address. The next time you type the letters DA, it should default and let you just choose my email address. So a lot of this process gets easier with second and third sessions. In other words, you don't have to go also to GoToMeeting website anymore. When it downloaded that file, it installed a shortcut on the desktop. So the next time is all you have to do is double click that shortcut, put in the meeting ID number, which I text to you each time. Every time there's a different meeting, it's a different meeting ID number, and that's how I get the meeting ID numbers to my students, is to text it to their phone.
Okay.
Okay.
Okay, so I just sent that. I sent it again to hopefully get you a little better.
Here, let me pull up my
quality. Honestly, I think the first.
So far, I haven't gotten anything.
Okay.
Oh, there it is. Yeah. Now,
all right. So
you can see my screen, right? Okay.
Yes.
Yeah. Okay. So I'll take this first one, download it. That allows me to open it up, and now I can blow it up, rotate it if I needed to. So you can see that resolution is fine.
Okay, great.
Yeah. So, however, did you send it as a large image or as a actual size image?
You're going to send it as large as they would.
I'm not sure the difference, to be honest with you. I always tell everybody to send it as a large, and some people have sent it as actual size image, and that I think works fine also. So.
Yeah, I think it's a matter of just compression.
Okay.
So that will affect it.
Yeah. Okay, so let's see. I guess the ones we want to look at are the ones you missed, right?
Yeah.
Okay, so number 4, angles 3 and angles 5.
So I said they were corresponding.
Corresponding means sitting in similar positions. In other words, excuse me a second. Let me take a snapshot of this so I can write. I use my drawing tablet. 6 and 5 are corresponding. 8 and 2 are corresponding. 7 and 4 are corresponding. You notice why they're corresponding? Because in other words, 5 is to the left of the transversal and above the lower line. 6 is to the left of the transversal and above its line. Now, if
Okay.
two lines are parallel, if T and A are parallel, then you can make a lot of statements about each of these angles. All corresponding angles are equal. All alternative interior angles are equal. Alternative exterior angles are equal. Things like that. If these two were parallel. Clearly, the way they've drawn it, they're not parallel.
Yeah.
6 and 7. Notice what they are. They're outside the transversal, or excuse me, they're outside the two lines T and A. They're not inside. 6 and 7 would be alternate exterior angles. Give me two angles that would be alternate interior angles.
2 and 1.
What else?
5 and 4.
Good, you got it. Okay, and finally 6 and 3.
Those would be same side corresponding angles.
No, they're not corresponding. I don't know that they have a name. I'm not familiar with their name. Even if T was parallel to A, I wouldn't know what to call 6 and 3. They're supplementary. That's what they are. Sorry. Oh,
Okay.
only if the lines are parallel. We don't know anything about 6 and 3. I don't know what they're called. Do you know? Is there another term that we haven't put on the first 6? You have a list of all the types of angles?
Yeah, let me grab it.
Because I'm not familiar with what 6 and 3 are. I don't think they're anything.
Okay.
Now, usually this lesson comes with parallel lines. And then they teach you all the names of them. And then they teach you what's equal to what. And 6 and 3 would be supplementary if the two lines were parallel, if T and A were parallel. They're not parallel. Yeah. I don't know what they're called. I honestly don't think they have a name. I'm not sure why this question was on there or what they want for an answer. He didn't tell you answers at all?
No.
Okay. Well,
Let's see.
Not worry about it. Unless you have a list of type of angles, read off your types of angles.
Yeah, one sec. I just gotta find it in the chapter.
Okay, from number 3, I can figure out what 7 is. Number 3 says same side interior angles. Or what are 6 and 3?
Same side exterior angles.
Yeah, okay, exactly. Same side exterior angles. Now, let me look at the rest of this page before we go on, because I think I want to talk about parallel lines just for a moment. I think that this is important enough to cover. It's one of the more important principles in geometry. Two parallel lines with a transversal. Always create 8 angles. 1, 2, let's just number them, 3, 4, 5, 6, 7, 8. And I understand that they teach you the names of all of these angles, and then they give you a bunch of theorems that says alternate interior angles are equal or congruent, alternate exterior angles are congruent. Well, here's an easier way to memorize. There's only 2 different angles in this picture. 1 and 2. 1 is obtuse.
Yep.
2 is acute.
Yep.
Look at 3 through 8. And if it's acute, it's the same as 2. If it's obtuse, it's the same as 1. To me, that's a much easier method of memorizing the relationship between these angles. And furthermore, 1 and 2 equal 180. They're supplementary. So either angles are the same or they are supplementary. That's your only two answers. So tell me everything that's the same as 1.
3, 6, and 7. Oh,
3 is acute. So find all the obtuse angles.
4, 5, and 8.
Correct. What's the same as 2?
3, 6, and 7.
Yeah. And to me, that's much easier to remember. Now give me another one that's the same as 1. Oh, you gave them all to me. I'm sorry. Yeah, you gave them all to me. But notice that 1 and 5 are corresponding, correct?
Yep.
They're on the left side of the transversal, and they're both above their parallel line. So that's why they teach you a theorem that corresponding angles are congruent. But I don't really need that theorem, as all I need to know is that all obtuse angles are the same in this picture, and all acute angles are the same.
Okay.
Okay? And if they're not equal to an angle, they are supplementary to it. 1 is not the same as 3, but I know that 1 and 3 are supplementary. So they're either equal or they're supplementary. It's as simple as that. And I understand you do have to memorize the theorems, but 5 years from now, when they talk to you about parallel lines, you will not be thinking of those theorems. You'll merely know that 1 is equal to 4, 1 is equal to 5, 1 is equal to 8. Okay? So let's go back to your drawing and scroll down and look. Let's see, we got 10 minutes here. Find the measure of each numbered angle. Well, notice that parallel sign there. Oh, you've got all these right. We can scroll down further here. How far down do I have to scroll? Okay, so that was the only thing you missed on this page was these. Okay, let me open up your next email.
Oh, I'm sorry, David. That's the same. I just sent another. I didn't know if we would have enough time to do both pages. So.
Okay. We probably do. I don't know. How fast can you take a picture and send it? I'll bet pretty fast.
Pretty quick. Yeah. Unfortunately, the dog literally ate the homework. So
I saw that I saw at the bottom of the other page. Yeah, it's not often that I see teeth marks at the bottom of the page.
Yeah, the German Shepherd.
Yeah. I guess that's teeth marks. I don't know. That's what it would look like if my dog got a hold of it too.
He snatched it off the. She loves to chew paper.
Yeah.
And so
my dog loves to chew paper if I've held it. If it's got my scent on it, it's gone.
Yep.
In fact, anything. If I've used a toothpick, leave it around, she'll get it. Yeah. Try to use it or something.
Shoes are a big one as well. All of our dogs always, you see them in the corner with a shoe in their snout, or their snout in the shoe.
Yep, I keep all my shoes up high. I've lost too many pairs.
Yep.
Actually, I have a great dog. Her name is Pie, but she had a real chew problem when I first got her. She must have chewed up $1,000 worth of stuff. But I love her more than I've ever loved any dog. She is very special. She got over that chewing. So
yeah, that's good. Okay, so I think that email has arrived.
Okay.
I hope. What breed?
My dog is a mix between a Chihuahua and a Terrier. More Terrier than Chihuahua. She's about 15, 20 pounds. So she's bigger than most Chihuahuas.
Mm-hmm. Smart dog, for sure.
Definitely a smart dog. kind of dog that watches TV. She does. She not only watches TV, she barks at all the animals. Furthermore, she memorizes the commercials. So if a commercial comes on that's going to have an animal 30 seconds in, she attacks the TV and waits for it.
Oh my goodness.
It's impressive. I know. Okay, so let's look at 17 here.
Okay.
Label which sides are bases and which are legs. The bases are always the parallel sides of a trapezoid. When you have a trapezoid, you have two parallel sides. Excuse me, I got that backwards. The bases are always the two sides that are not parallel. In other words, on this picture, here, let me just draw a line through the bases. In other words, that's base 1, that's base 2, or vice versa. And it's important because when you're figuring out the areas of trapezoids, it's the average base. So you have to take both bases, add them together, and divide by 2. Multiply that by that height, which is consistent throughout. That's the area of a trapezoid.
Okay.
So the bases would be BC and AB. Okay. How about number 20? What postulate or theorem allows you to find the measure of angle D if you know the measure of angle A? Okay. First of all, tell me everything you know about trapezoids. What do you think the relationship is between those two angles?
They are probably supplementary.
Yeah, just by looking at them, they look supplementary, right?
Yeah.
Well, they kind of do. In other words, this is an acute angle. That's an obtuse angle. When you add an obtuse and an acute, then yeah, and the theorem that they're asking about is the, I guess the two sides opposite the right angles are supplementary. I don't know if that's how the theorem is worded or not. You put angle addition or subtraction postulate. The angle addition postulate says this. Angles 1 and 2 equals that. That's what the angle addition postulate means. In other words, if I have an angle and I make it into two angles, even if they're not equal, I know the sum of those two angles equals that full angle. So that's where you would apply the angle addition postulate. Here it is the postulate that regards trapezoids.
Yeah.
Are you looking at your book?
I am, yeah.
Can you figure out what the name of that theorem is? The one thing I don't usually memorize is the names of theorems. First of all, they're not particularly important to know. What is important is what the theorem means. That's what you want to memorize. Whether it's called, whatever it's called, you'll never have to know it again after you get through geometry. I do understand you have to know it to get through geometry. Have you found it yet in your book?
No, not yet.
Well, basically, when I have any trapezoid, let me just draw a couple of different trapezoids here. I can draw a trapezoid like that. Okay. Now, let me think about this for a second. Yeah. In other words, notice I oriented it slightly different. You've got the two parallel sides being vertical lines. I've got the two parallel sides being horizontal lines. In this trapezoid, what I know is that opposite, ooh, what do I know? If I were to draw this in the same style as you drew it, and I said that was X and that was Y, those are supplementary, and that's what that postulate says. And the only way I can kind of think to define it as the two angles in between your parallel lines, right? In other words, I'm not quite sure how to define that with words, but that line is parallel to that line, and my X and Y are the two angles that are between them, as well as A and B. Well, I can say that X and Y are supplementary, and I can say that A and B are supplementary. They are the two angles between the parallel lines. Now, I don't know what that postulate is called or theorem, but it's undoubtedly a trapezoid theorem of some kind.
Yes.
But notice I cannot say adjacent angles are supplementary because Y is adjacent with B, and they're both acute angles. So there's no way that they are supplementary or equal.
Okay.
They could be equal, but not the way I've drawn them. So I can't really say anything about Y and B. But the two adjacent angles that are between your parallel lines, in other words, X and Y and A and B, those are both supplementary. I've got an obtuse and an acute, got an obtuse and an acute. Not that that necessarily makes them supplementary, but in trapezoids it usually does. Okay.
Okay.
And that's the way you want to memorize that theorem, is the two angles between your parallel lines, the ones that are adjacent, are supplementary.
Okay.
Okay. Why don't we end it there? That's a good first session. Should have given you a chance to see how it works and
Okay.
a little bit of how my tutoring style is.
Okay.
And let's see, you have another session scheduled, I believe, don't you? Yeah, on Thursday at 5. So
Okay.
on Thursday at 5, what I will do is text the meeting ID number to whatever phone number you want me to text it to.
Okay.
What is that?
You can go ahead and send it to mine, 303-549-6798.
Okay. That's the number I'll put in my contacts list, and like 1 or 2 minutes before 5 o'clock, I will have him send that. So if he wants to send me, since, well, regardless of how long the session is, if he can send me the material prior to the session, saves time, allows us to spend more of the half hour on problems instead of waiting for emails to arrive.
Okay.
So
sounds good.
Have him send whatever he wants to go over that day to my email address, and then I will text your phone number, Joe, right, to your phone.
Okay. I think.
And you have to go to meeting software now. If you look at your desktop, here, let me just show you what it looks like. See that flower over here on the far left? That's what that icon should be on the desktop of that computer you're on.
Okay.
Okay.
Yeah, you got it.
Click on it. It'll be waiting for a 9-digit meeting ID number.
Yeah.
Okay?
Yeah. I think we'll try to maybe do sort of a general review of the quizzes he's had, kind of get him prepared for the final exam in a couple of weeks.
Okay.
Like
I usually let the student direct, or the parent. I mean, either one, but I don't direct because I don't know where he's weak and where he's strong at this point. So
Yeah.
I let the student try to tell me what problems he wants to work on.
Yeah,
Okay.
we'll spend the next couple of days trying to collect these major tests and quizzes, and then use those as
Yeah,
points of.
that's a good way to start, actually, a very good way.
Great. All right, well, we'll let you go, David. Thank you for your time, and
All right, Joe and Jonathan, nice meeting both of you, and we'll talk to at least Jonathan on Thursday.
okay, sounds good.
The way you get out of this program is just to click on the Go to Meeting X in the top right.
Okay,
And I close
great.
it out. Bye-bye.
All right.
Have a good evening.
Thank you, sir. You too.